online discussion. So we all agreed to have a little bit of a chit chat about WebAssembly, especially on the client side. So having a discussion how it has been performed over the last years and how we think it will further evolve. And thanks for being around today. My name is Lars König. I will host this session a little bit. So maybe first we go for a quick introduction for everybody who looks at the recording later. Simon, maybe you just say 2 words about yourself.
2 words. That's just my name is Simon Hausmann. That's already more. Yeah, I'm a software developer. I'm a co-founder of 60FPS. We're creating a GUI toolkit for embedded Linux and for desktop, and we use Rust and C++, and we use WebAssembly to try out things, to show off demos running in the web browser.
Thanks, Noam.
Hi, I'm Noam Rosenthal. I'm an independent consultant for working mainly on browsers and standards, Chromium WebKit contributor, HTML standards, and sometimes I do freelance web development, so I encounter WebAssembly from both sides of the browser platform.
Thank you. And we have also, last but not least, Syrus with us here from California.
Yeah, that's right, from San Francisco. So hi everyone, I'm Syrus, founder and CEO of Wasmer. Wasmer, for those that don't know what it is, we are like a server-side WebAssembly runtime. So we are taking like WebAssembly and we are allowing people running outside of the browser. And about myself, I'm from Spain, so that's why you will hear a little bit of accent from my side. Been living 7 years here in San Francisco, California, and yeah, but usually go back to Europe, Spain, more or less like twice a year.
Challenging these days going back to Europe.
Yeah. I mean, COVID times, traveling, it's always challenging, but I think Spain right now is doing pretty well. So I'm looking for going like in the next month or so.
Yeah. Okay, thank you. And my name is Lars König. I'm founder and CEO of Crossware. Crossware is a cross-platform software service provider. So we build solutions for many different platforms and deployments. And that's actually also the reason why we are interested into WebAssembly, just because we believe in WebAssembly. We have watched that development for some time, but we also see sometimes it stuck a little bit here and there. And I'm just curious today, what do you think, how it will further evolve and why it has been stuck? So let's have a nice conversation around that. Just to start that today, I always felt, so this slide you see here is something I built, I created a few years back and thinking, hey, about what is the opportunity of WebAssembly? And I realized at that time, hey, it could be really the perfect deployment format for many different scenarios. So being on the web, it was at the beginning meant for the web as being for a native format for web deployments. But also it further evolved to other scenarios with WASI, and I thought, hey, it could be used in the cloud, but also on machines, on mobile, and even on the edge, and so on headless devices and so on. And for me, it was also the perfect thing, just because you could do everything what you want. Yeah, you could do Rust if you want. You can do C++, assembly script. So it's kind of multilingual or polyglot. And of course, it was also from the concept perspective, pretty much a modern thing. It was secure from the design. It was always as close to native. It is also sustainable, just because it has low footprint and low overhead, and also pretty flexible. I thought of, hey, you will end up having a micro application architecture at the end. And I thought maybe that was a little bit of too much dreamful thinking, but it will eventually be everywhere. But we are not there yet, yeah. And perhaps maybe the question to Syrus, so where has been WebAssembly successful from your end and where not?
So I think WebAssembly have like a lot of interesting edges where it's being used. For us as a company, like where we identified there were like 3 or 4 major ones. On one side, we have blockchain, which is they are kind of like the precursors for using like WebAssembly server side, I will say, are one of the first ones that realized the power of very easy sandboxing through that. So we have blockchain companies using WebAssembly server side to run secure smart contracts or smart contracts securely. That's on one front. On the other front, we have the CDN or edge computing space, which we can kind of like put all together, not just like CDNs, but like serverless, CDN, edge computing, and so on. So basically, like one of the trends that we are seeing right now is moving computation towards a more decentralized paradigm. So if until now, like computation was done in Google servers or Firefox or Amazon or Microsoft servers, and all the computation was done in servers that are very homogeneous, basically like it's always the same kind of chipset and the same kind of operating system. Right now, we are seeing a trend towards more heterogeneous systems. So for example, when 5G comes and we want to move computation towards antennas, these antennas don't have like x86 Intel chipsets. They might have ARM, or they might have like RISC-V in the future, or other kind of operating systems that are not Linux. So in that sense, moving computation towards those places is much more challenging. And WebAssembly is kind of like it's a nice abstraction to be able to run software on those places. So I commented blockchain. I commented serverless and edge computing. And the other one that I think is quite interesting, it's IoT. Basically, like on the sense of moving computing towards more devices, IoT is kind of like the obvious one that is growing. It's still very, very slow, but it's growing. And aside of that, one other field that I don't think it's related to any business, but is very important for developers, is to be able to create libraries that work anywhere. So the concept of universal libraries that can work in your language, either if this language is JavaScript or Rust or Go or Python, basically like being able to have a library that run anywhere, it's also like super, super powerful. So this is kind of like the use cases where we are seeing the usage of WebAssembly be more prominent right now. But it really, there are like tons to be honest. These are kind of like the 4 that I kind of like identify, especially as well when talking with investors and trying to see where can be like the gains if a company enters into this ecosystem.
I understand where it really has momentum, like the CDN stuff, server side and blockchain, and you also outlined a little bit where you see the future, like the IoT. I will get to that in a moment, but of course it has. So it's rich, so it's coming from the web, right? So it's coming from the web development. And I still see a lot of people thinking. So there was recently from Scott Logic a blog about the state of the art of WebAssembly. Many developers believe into WebAssembly, into the web, and I'm not sure there. So Noam, what do you think? Why? So has it picked up? And if not, what was the problem?
I think ever since you invited me to this panel, I thought deeper about this question. I think the problem stems from the misunderstanding of the word native.
Yeah. So
WebAssembly could create a code that is native to the CPU and maybe to the memory, but WebAssembly is a disparate runtime from the platform of the web. like from the bigger picture, it doesn't have access to the network, doesn't have access to disks, doesn't have access to your native images. At a lower level, it doesn't have access to your strings. Like to pass a string from the DOM into WebAssembly, you have to encode or decode them to UTF-8. So really the WebAssembly runtime is kind of a sandbox, unnative, if you will, environment inside the web. It's a foreign environment inside the web, which needs usually a very rich glue layer between that and the actual DOM and network and all this things that are the web platform in order to work. So where it shines is when the computational heavy tasks are worth it to require all that glue layer with the platform. Now, many times when you need heavy computational tasks, it's not that the web didn't have solutions for that. It did. It's called server side. So the web always had that in the server, and that's why also WebAssembly and Wasmer great on the server. That's, by the way, is the exact same reason, I think, why Java applets was a big thing, and then Java became a server thing and an Android thing. And in Android, Java is part of the platform, is not a sandbox runtime somewhere that needs a whole bunch of hooks. On the server, it's usually like WebAssembly needs WASI. It needs something to connect it with the platform. So when you say why WebAssembly doesn't work, didn't catch up on the web, it's not that it didn't. It didn't catch up in client side. That's because it's stuck in the middle in the use cases between things that JavaScript handles much better because it's closer to the platform of the web. Think about simple things that we don't think about much, like streaming while loading the JavaScript and the CSS and the resources. That the web is so good at that, like prioritizing what you load first and showing just what you see on the screen and then showing things later. WebAssembly is totally unprepared for that. There is some talk now about streaming the code as it goes along. It's beginning to materialize now, but it's way behind where the native web platform is in that regard.
You say it's kind of you said it's way behind. It's kind of you don't see really a big future of WebAssembly in the web, or is it? Is it rather a niche thing for you?
Well, you have on the other hand things that are done great on the server.
Yeah.
Like that you don't need a new solution for, or it's better done on the server. So right now there is a niche for WebAssembly, which is a compatibility layer. Which is the major use case right now for WebAssembly, not the only one. Compatibility layer, which is what Siemens does with it, basically like a way to display and use things that are meant for other platforms, like AutoCAD Web is using WebAssembly to take their extremely huge C++ code base and deliver it on the web. It makes total sense. TensorFlow, where you have a lot of numbers, where you need a lot of work with numbers and you don't, for some reason, you don't want to go to the server, is where WebAssembly works. As for the future, I think the question is beyond WebAssembly. It's about the web platform in general and how it's going to look like. Like, how do we envision people developing for the web? Right now, there is this WebAssembly separate runtime, which you need a bunch of hooks to connect it to the web platform, which a lot of it is defined not by the JavaScript language, but by WebIDL, which is the APIs, hundreds of APIs that are the web, really. and are currently available through JavaScript. So how do you build with Rust and WebIDL together? I think that's we're 3 steps behind that. Like we're totally not there yet. There's talk about that, but strings are not defined yet in WebAssembly. There's totally different. Rust has 10 types of strings. JavaScript has 1, and DOM string is 1. There's so many low-level things to do before WebAssembly would be native to the web. Threads currently don't work on Safari yet because the whole thing with shared array buffers and Spectre are not completely done yet. Those low-level things are several steps before you can think of WebAssembly as something that is native to the web platform. I spoke a lot.
Yeah. It sounds, yeah, I get what you say, and that's there are certainly some challenging things ahead for WebAssembly, and I understand you. So it might not be the perfect environment for WebAssembly. It might rather go into the IoT space. Yeah. So Simon, what do you think about? So you're pretty much in the embedded space, I would think. Also from the UI perspective, so as Syrus said at the beginning, do you think it could play a good role in IoT and embedded space, and being a deployment format there?
I don't see it there right now. I'm actually very curious to learn what other people see as an opportunity there or not. I buy into some aspects of it, which are interesting, but I also don't buy into others. So, for example, the idea that you don't have to compile your code for different target architectures, not for x86 and ARM and RISC-V. I don't buy that argument. I mean, that is an argument that I think was very valid a few years ago, but I think that is an argument that is vanishing over time as software is generally more portable and as it's quite easy to nowadays to cross compile to I mean, the dominance of ARM basically introduced cross compilation to, I think, more software developers than anticipated. And then on top of that comes the fact that what WebAssembly offers by bundling things together, and what makes the deployment so easy, is that you have basically one binary file that you ship across, one binary blob. That is an advantage that I think applies mainly if you're coming from the C++ world, where static linking is really difficult to achieve. But if you use languages that sort of natively produce statically linked executables like Go or Rust, then you don't really need that aspect of WebAssembly either. So those are things that may be relevant if you're building an embedded system where you want to make the deployment easy, make it easy to update these things. But I don't see the WebAssembly there right now. And plus, then there is this entire interface layer missing. Like what Noam said is that it's not really native to the browser because it's missing a lot of the glue, and there is something missing. But on the other hand, I'm very glad to see that WASI is experiencing momentum, and it is being extended and being built upon, and the foundation is being laid there. So who knows what's going to happen in a couple of years, and it could very well be that it becomes more popular again.
Yeah, I give Syrus, you're the WebAssembly guy. You can counter-strike what the other two guys said. So I don't know if you have something to say about that.
So on one side, one of the obvious use cases that, like when Noam speak, I completely miss is like, yeah, of course, WebAssembly on the web. How I did miss that? Yeah, I think it's I actually do think WebAssembly without without like being able to target the web will not have taken the steam and the heat that is taken. So I do think WebAssembly on the web is essential to assure the success of WebAssembly on the server. And without that, actually, like it will be almost impossible to attract as much attention as WebAssembly is gathering right now. So what I mean is, if WebAssembly in the web was not a thing, perhaps like not even Rust will care about like targeting WebAssembly, and therefore like it will not warm up other things that like pushes the ecosystem forward in general. So I do think like having like WebAssembly on the web is a very clear catalyst of the whole ecosystem. So yeah, I'm like full into making computation basically like possible in the browsers and outside of the browsers, but on both at the same time. I think it's a very compelling story. And regarding what Simon commented on the IoT, it's true that it's super early, right? Like IoT is still kind of like not super. Is not the $1 billion market or the $1 trillion market that like it will become in a few years. On the side of cross compilation, it's true that right now, especially like since a few years ago, ARM is kind of like making a comeback on the server. We are seeing kind of like more ARM chipsets, for example, in the Mac ecosystem or Apple ecosystem, and this is just only expected to grow, right? And this is making the developers realize how important it is to have like a cross tool chain that is easy to compile to other platforms and so on. But I do think we are missing the viewpoint of right now. Let's say like you want to cross compile. It might be the fact that the chipset that you might want to become available for the program that you're writing is not yet available. Like let's say like RISC-V is gonna become important for your program in the future, but your program right now is compiled to other architectures. And let's say you wanna compile into this architecture in the future. Right now, if you want to kind of like assure a whole, or to make sure that a program is able to run on more devices, you actually need a whole tool chain to be able to compile it. So let's say like you need a specific version of Go or Rust or whatever, and make sure that everything is working properly and so on, and install all that tool chain to then be able to cross compile. I think WebAssembly adds sort of like a neat quality, which is it once you compile it to WebAssembly, you start worrying about the tool chain. So I do think that's kind of like an important aspect, because right now, like let's say even if you're targeting an IoT, you need to have like your Clang, you need to have perhaps kind of like some libraries that your library is using, or some headers to be able to compile to a specific platform. And I think the beauty of WebAssembly is it removes the need for that. So once you compile into WebAssembly, it's very trivial to then compile into more platforms. And I think that's kind of like a nice addition. But I do agree with Simon in the front that like it's very early, and like the usefulness of it is still like not super high, because there are a lot of roadblocks. Like it's not easy to enter on that ecosystem, right? Like it's actually like it's more painful. Like if you're trying to kind of like cross-compile or compile to WebAssembly and then cross-compile to other architectures, that right now like it will be like super painful. So I can understand kind of like why right now like it's not the easy path, and probably like not the one that most of the people are taking.
Yeah, I'm actually I agree a little bit with you. So Simon and Noam, they are just they have a little bit of the developer glasses on, and they just pull together what they need, and then they have everything up and running. But I'm thinking also a little bit beyond. So I just want to have something that is already ready for use. And if you last need a development environment to set up, you just use existing libraries, deployments, and the APIs for that, then you can just pull your things together, and it would also work across companies, across deployments, and so on. So you can do some kind of compositing of your solution, which is not only in your sandbox. So that is a little bit of my future idea of that. I don't know how much that is far out from the if it's doable, but it's at least it's my future wish and dream. Yeah.
I think this compositional aspect is something that is indeed quite interesting about WebAssembly, but it is currently missing, or it is not well established yet. So the idea that you can compose different libraries together, that is something that is not existent right now, but that is necessary to achieve the vision that you described. And I mean, the fact that now that like in Clang you can create object files, or that there's the concept of relocations in WebAssembly now, and that you can link these things together. These are all really important steps that go, I think, into the right direction to be able to achieve composability on a much more integrated level than just WebAssembly modules. Like communication across WebAssembly modules, that has a different use case, and that is a use case that I think might actually happen sooner than later for WebAssembly, because, and so as you have developer glasses on, I even have a hat on, and that hat indicates that I'm very passionate about making software development itself easier, because I find that still very, very hard. And especially in the IoT and embedded space, software development is hard because it's difficult to get a quick turnaround. It's difficult to make a change and see it on the device and see whether it actually works or not. And of course, having a large statically linked executable to upload every time onto a device or to flash onto your MCU, it takes a long time and it's not very efficient. Whether it's WebAssembly or whether it's an ARM binary, the size is roughly the same, and it's going to be big the bigger your application is. So I think one use case I could foresee is that perhaps in more complex applications where you have more dynamic elements in it anyway, that you might at some point say, okay, maybe I have a plugin system, or I have a scripting element in my application that also runs on a device, and that one I'm going to base on WebAssembly, so that my application on the device maybe runs a WebAssembly interpreter or maybe even a JIT, but it can dynamically load little plugin modules that the developer just pushes onto the device to just replace that functionality that they want to test, or that they want to play with, or want to change and see what is the effect of it. And that could, maybe that is something that will become, or will make it more attractive and that would organically happen anyway, is if people discover it and how easy it is maybe to embed one of the many WebAssembly interpreters in the application and replace their own scripting interpreters with that.
I think also when we talk about the embedded and IoT space, it's not one space, or it's a very broad space, like and it contains several platforms within it. At the lower end, even if you look at things that are real-time embedded, like Arduino and its counterparts, anything that adds 1 kilobyte of code would not do. like the cost of any little piece of abstraction is so felt that it will take a while for something that is dynamically loaded to be worth it. When you go higher up the stack towards, let's say, TVs and things that have more memory and more disk space, there you see more platforms like Android right now. And I think there, WebAssembly could be a component of a platform. Like if there was a platform for TVs that incorporated WebAssembly as a way to load native plugins, like it's missing that link. Just taking WebAssembly and plugging it into TVs, it's missing that. What WASI does for servers, or what the DOM does for the web, like the platform, it's missing that part a little bit. It's just it again would be just a foreign computation runtime. If you just try to stick it on an IoT device, it's like it could be something, a challenge somebody could pick up, like how to make an IoT platform that takes advantage of WebAssembly. Maybe people are already doing that. I need to catch up.
I mean, it could perhaps be as simple as saying you extend WASI by all the things you need to just have the Wayland client running. So that would cover Wayland as a well-defined interface for handling input and output. If you have that built into WASI, and then to get already have a relatively minimal API, nevertheless, a very minimal extension to WASI. So the smaller it is, the easier it is to implement, the easier it is to deploy, get momentum. But you already have something that might be powerful enough to be used, and to still you get that sandboxing, etc.
All right, who's buying the .io domain?
What is it? WASI?
Okay.
Yeah, what is needed? So you have you spoke about what kind of niche it was. So in the IoT space, certainly TV is, for me, TV is less an IoT device. It's rather a platform. So good IoT devices are, from my perspective, usually a little bit smaller from the form factor than a powerful TV. But there are other industries where it might be worth doing it. So with a little bit more constrained devices. So somewhere between like a microcontroller thing and a TV, there's certainly some space. But also, the other part is, what is the developer experience we need as next? So who provides the developer experience? Is it set up, or is there still a gap?
I do think there is a huge gap. Right now, WebAssembly is still, it's still hard for people to kind of like to target and to wrap their head around, especially because like one of the things that like both Noam and Simon commented is that like it's even hard to pass a string around. So something as simple as a string is like not trivial to do. How we're gonna expect like people that like don't have like very low level expertise, which usually happens like for most of the developers, how we can expect them to use WebAssembly easily. So I think on that front, there is already like a lot of push from the industry on that front. So WASI is just kind of like one part of the picture. So WASI right now, like as it is just a API that provides sandboxing to the file system, and that's it. Right now, there are the push that like some companies are doing, especially like people for example from Fastly and so on, are working on a new set of interfaces that allows like for representing easily how what are the types within your WebAssembly module, and what are the functions within those types, or what are those types within the functions, and how things composes and so on. So basically, like there is a missing layer right now, which makes easy to use WebAssembly from the function perspective. And this thing is being built right now. So there is a standard called interface types that people are from the WebAssembly ecosystem are trying to push forward. There is even like a very early implementation of that is basically prototyping some of that stuff. And I think that is going to ease a lot the usage from a developer's perspective. But that's once things are already compiled into WebAssembly. And then we have the other part of the picture, which is how about compiling into WebAssembly? That's still hard. The only language that like allows you to compile easily into WebAssembly is Rust. Then there is a toolchain on top of our language, which we have like MScript and to be able to compile C and C++. But like Go compiling to WebAssembly is still like not WebAssembly native in that front. It's basically like very JavaScript oriented. Other languages right now, like I mean, people from Fastly are doing like super awesome work on some of those efforts, actually like even compiling JavaScript to WebAssembly. They have not published anything yet, but like if you sneak into what are they working on, it's quite interesting. They compile SpiderMonkey, which is the engine from Firefox, into WebAssembly WASI, and then they are pre-compiling the JavaScript into the bytecode first to basically speed up startup. And I think we still need more of that ease to be able to compile to WebAssembly. So it's both like compiling into WebAssembly and then using from WebAssembly.
Yeah, but I hear something which is something new to me a little bit. So I believe that you said that Rust is the most comfortable programming language for WebAssembly, right? So there's, and I hear more and more that Rust is getting so popular. And it's just a cool language. I don't know much about Rust, to be frank, but will it be that route, saying, hey, all the Rust community driving the WebAssembly development and usage at the end? No?
I mean, I think WebAssembly is already, it ticks all the boxes necessary for Rust to work well, apart from maybe even the strings. I mean, it's already dealt with really well.
Okay.
So I think this is more in the other languages, like any garbage collected language needs some features in WebAssembly to work really well, and to not bring their own garbage collector, but to allow using a shared garbage collector. And that's what Syrus mentioned. There's work going on. It has been going on for a while, and when these extensions hit the major browser platforms, then I think that will be a catalyst to enable better ports of garbage collected languages, basically memory managed languages, and that happens to be where C++ and C and Rust have an advantage. But that means I think they're basically happy, and for them it's all right and it's okay. I think the push will come from other languages.
Okay.
But that's at least where the drive is.
I think it's going to increasingly become a competitive advantage from languages, from the language ecosystems. So basically, like right now, like Rust is kind of like catalyzing a lot of that. MS Scripting or with or C++, like it's also like doing kind of like good work there. But I think as languages want to still become relevant or still be relevant in the future, they will want to target the web. And they want to be kind of like up to the capabilities that you can do with other languages. So I think it's going to become a competitive advantage, and because of that, most of the languages will try to compile into WebAssembly. So I mean, right now we are getting like Swift, we are getting like even like Java with TVM and other like compilers that compile all Java bytecode into WebAssembly. So I think it's warming up. I'm hoping like at some moment like all languages will be able to compile to WebAssembly. Just from my point of view, it's just a matter of time.
The question I have about that is like, what's the benefit for users and developer for that to happen? Like maybe we want that as people who care about WebAssembly, but why does the world need that?
So that's a really good question, because I mean, with originally with WebAssembly, that was very clear, right? The reason why we want this is because we want to play the Unreal Engine in the web browser. So that goal has been achieved. That is where WebAssembly came from. That goal has been achieved. Done. It ticks all the boxes for that are ticked, and that was an amazing push to see. I was very skeptical at the beginning, and then it took a while. It's like, oh yeah, this is great. This is actually really good. And now that level we've reached a plateau here, right? So the question is, what would be the major benefit be for the users and developers to achieve a new level in terms of user experience that happens to be where WebAssembly plays a role, perhaps. And it's not evident to me either yet, at least not when it comes to web applications.
So from what I see, I actually think like the web has been like uniformly JavaScript, like up to now, and usually like what happens is about like ecosystem dominance, like basically like what's the language that dominates certain, basically the web and so on. And I do think right now, like developers need to learn like multiple languages, like if they want to target like front end and back end and so on. And if we want to enable kind of like more developers coming into the web and making like more applications, I think it's important to enable them to do it in the language that they feel more comfortable in. So for example, Python on the server is ultra popular. On the browser is of course like not popular at all, because like it's obviously, like if you want to run it, which is possible, it's not like trivial to do it. But if you make it super convenient, let's say like you don't have like a 20 megabyte or 5 megabyte file from Python to be able to run it on the browser, and you just have like a 10 kilobyte one, then it becomes much more compelling. So I think as we see those things, we will start seeing like more developers targeting the web with the languages that they feel more comfortable. One example of that is Dart, Dartlang or Flutter. Flutter is like, or Dart is a language that was created by Google. It's like, it can target, it has their own VM, it have like their own syntax, which is very similar to ECMAScript or JavaScript. But at the same time, one of the very cool advantages of Dart is you can actually target the web and paint in a canvas, or you can target like your phone and run it natively on your phone. And I think that's a very compelling use case that on the Dart side, it's just kind of like you're only seeing from one point of view, which is kind of like one language to dominate them all. But I think that use case is still very, very compelling. So I do think the use case of Dart kind of like showcases how useful it is to have one language that allows you to target almost any platform from the knowledge perspective as a developer. Kind of like just know one, you don't give you don't care.
That's but then okay, I get it, and I like that as well. So it's it open up doors for developers if they have an existing knowledge and you want to use it in other scenarios. Yeah, but there's what I like to steer the discussion around a little bit to something else, if you don't mind. So the company push. Do you think any companies pushing that more in future? I heard from. Yeah, I know Fastly, for instance, using that on the server side, and perhaps they might be ones companies being a company who push that to a certain direction, saying, "Hey, these are the ones who make it happen at the end of the day." It might not be only the use case or the developer experience; it might be just the company pushing it.
I mean, to be honest, everything has to start from somewhere. So having companies to push it is awesome. Having billion-dollar companies to push it is even more awesome. So yeah, we are seeing like a lot of companies. We have Fastly, we have Crossware that is using as well like WebAssembly on their infrastructure. We have, as they mentioned, kind of like AutoCAD and other programs kind of like compiling to the web. We have Apple actually, like they very few people know this, but like they are starting to allow like Swift compiling into WebAssembly. And one of the cool things is there is a new framework that not Apple, but people related to that ecosystem are pushing, which is like being able to build HTML pages with the Swift UI kind of like syntax that all the people on the Apple ecosystem knows. So I do think like there is a lot of, from my perspective, there is a lot of company pushes, but these pushes are very unbalanced right now. So we are seeing kind of like on the infrastructure side, we are seeing a lot of kind of like use case on the CDN space, like Cloudflare, Fastly, and so on. We are seeing kind of like on the browser space, still kind of like a lot of push. Basically, like companies want to compile their programs into WebAssembly to target the web. I think we, on the server side, we are still missing some push for the universality of libraries with WebAssembly. So just as of, for example, 2 weeks ago, we learned that Brave was using Wasmer to scale images like on server side, like with one program that runs exactly the same way on Python and Ruby, and they can target like from different services. But like this push, I think is still like super small from like what is going to be in a few years. From my perspective, I of course don't speak with the truth, so I have no idea.
Yeah.
I think are pretty accurate or not.
We all don't know the future.
I'm curious here on the first part that you were talking about. I'm curious on Noam's opinion here. That you were talking about, Cyrus, you were talking about Swift UI or Swift UI like syntax compiling to the web, and the same thing with Flutter, right? The Flutter has a backend that can render to canvas, but they also have a backend that can create DOM elements. And so then we have something like Flutter or Swift UI. Building a DOM and manipulating a DOM, and that's competing with more, say, the native frameworks on the website, like React, for example. I wonder what Noam's take is there in terms of how do they compete and what makes the competition meaningful or not.
Well, Flutter for web, I'm a fan of Flutter. I think it's great in the Flutter web and creating compatibility in that way. But as far as WebAssembly plays into the role, like you get to the point where your runtime has to speak with the platform, and I'm afraid that the Swift UI and running Dart rather than compiling Flutter to JavaScript would run into this, where the sweet spot of WebAssembly would remain a compatibility layer rather than a major, rather than like the native layer for the web. The way that the web is written natively. It's a little strange to say that, but when you target the web, like the major way would still be JavaScript, and then you would have compatibility layers for writing things in different ways. And I think to surpass that, there is a major thinking like paradigm we need to cross with thinking about what WebAssembly needs to be. I don't have an answer to that, but it's beyond compiling this or that language to WebAssembly. It's something in the API layer, and thinking it's the same way, Simon, you were talking about the Unreal Engine. What thing can't you do with the web right now? Like Swift style UIs you can build with JavaScript right now, and same as Flutter UI. It's maybe not as convenient from a developer perspective. Syrus, you were speaking a lot about the languages and the developer perspective and the compatibility. Yes, you can use one language to write them all, but you could still do the same thing with JavaScript. And from a user perspective, what can't be done right now, like the Unreal Engine, or can't be done right now with this performance, and including not just FPS but Mbps into the loop, because we're in the web. There's the network. There's streaming things that load in different race conditions that the web platform is so good at today, and still not there yet, but evolving all the time. And just moving to a foreign environment would require so much work. So I'm missing that paradigm shift that would say, oh, I can build this with WebAssembly platform in a better way than what JavaScript and the current web platform can do. I'm missing that.
I actually fully agree with your point. You made a very good point, right? It's kind of like, okay, you're gonna open the world, but like, what's the possibilities that you're gonna open, right? Like, what is going to be kind of like what was not possible before that is possible now? And I think that's, to be honest, that's a very good point. I don't have a counter argument to that. But I do think it's, for example, certain ecosystems empower new use cases that were not as easy to do before. So one of those things that I think are going to be empowered is we are thinking, like, for example, use cases for WebAssembly within the machine learning ecosystem. And for those, and basically there are new standards growing, kind of like ONNX or TensorFlow and so on. And being able to kind of universalize that or crystallize that with WebAssembly, that's kind of like a very compelling story. And that's on one front, and I think on the other front is, I do think by enabling frameworks that were not available before, it's kind of like if the web was only React, we will be doomed. Or if it was only Angular, or if it was like just pick one, like I don't care, like just pick whatever framework. But the fact that we have many more choices, and we have Vue, and we have Angular, and we have React, makes kind of like certain new cases or new use cases to flourish. And I do think if we expand even more the ecosystem of languages, we are going to see use cases that were not like trivial to do before, that perhaps with a new ecosystem becomes trivial. So, for example, right now, people that want to target WebAssembly is because of on the web is because of the speed, right? They have a bottleneck on JavaScript, and they want to kind of like solve it and have implementation is much faster than in JavaScript. But I do think we are going to see also use cases by empowering new ecosystems. So what I mean with this is, for example, Lisp makes for like a really great kind of like compilers in general, like basically like parsing ASTs and so on. If you enable Lisp on the web, then they are going to enable kind of like certain ecosystem that was not existing before, that perhaps is going to create the next generation of language. So I think that's kind of like the compelling use case, but I do agree with your point on like, okay, what was not possible before that is possible right now with WebAssembly? And right now, the main answer to that is just speed. So of course, like you have on one side JavaScript, on the other side Rust or C or whatever, and then the problem is solved. So I do agree with you.
Maybe that has been a good final word. Maybe we take it, we close it here. I really like the conversation with you guys. I hope we do it one day again. Maybe we conclude what we have been spoken about in 2021. And I really enjoyed talking to you, and I'm looking forward how it will evolve and which direction it will take. As said, nobody knows from us how the future will look like, but it will stay for some time. WebAssembly, it may take off. We will see. Thank you all.
Thank you.
Thank you.
Pleasure.
Yeah. Bye-bye.
Good chatting with you.